Okay, here's a bit of an interesting one. And see if you can hear the thunder rumbling away in the background here. Hang on, let me get the light. So that's not really much better, it's more echo, but anyway. I do have a second light. Oh, I won't worry about it. I was trying to zoom in well with this. So this is a schematic of this. I'll better show you so you know what we're looking at. So this is a data precision 2480R multimeter. And just trying to think. I did take a video of, I think it's gone now. Anyway, I'll explain what happened. So this guy here, this little transformer. So we'll look here. The back of it was on the back of the thing here, sat in there. And as you can see, it's not looking the best. I'm just trying to zoom in. And anyway, so this has been leaking, and I've just, it plugs into 240, the transformer steps it down to like 7.5 volts. Across these caps here. So you can run off 240 volt, right? And this time it's short, the transformer's shorted. Blow the fuse of the mains, well, blow the mains fuse every time you did something, so it's had to go. So I had to cut it out, because don't try and unsolder the thing, because otherwise, it just heats up. The transformer just doesn't, get anywhere. So you got to, it's not focusing. You got to, you got to cut them off. So I got the hacksaw and cut it off, and the transformer leaked all down the PCB and all across here. So I had to wash that all, and you can still see if I go down in here. Still see that it's a bit corroded, whereas I go over here and see these nice shiny. That's all corroded. That's a new resistor as well. That one had broken. So R19, which is, I'll go through it later on. I'll just walk through. So the basic operation of this. So obviously we've got our two strips here that, I'll try and zoom out again. Obviously we've got our two strips here that get to our LED. This guy doesn't drive the LED. It's not that guy's job. I'll get that whole thing out of the way. So we'll start off here. I think these are just the shunts for RF, for measuring current, but I'm not sure because I haven't looked at that part of the circuit yet. But so basically here we have our Q, that's where our DC, AC, ohms, whatever signal. We go across here, across this little IC, up to this IC, and then there should be another one, this one here, and then we go across into this guy here. He's doing all the work. This guy here is a reference, 100 kilohertz reference. This guy here is a little power supply. There's actually little transistors in this thing, you call it. It's a LM. I can't read it. But anyway, so that's part of our power supply. We've got a few different voltages here. So we've got 7.35. We've got negative 6.8, and we've got plus 10 volts, and I think that's about it. So not really much to it. A lot of buttons here on the front here where you can sort of change stuff. So what I'm doing is, so there's a little, I'll show you the schematic here. So there's a 240 volt that goes in where normally our transformer would be. But this little battery, BT1, so you can actually run these with a battery, and someone's broken the lugs off here. You can actually run these with batteries, and be about 7.5 volts, so by the time you put the cell in. So I've just run some wires out, and I've just hooked this up to my power supply here, and I've got that hooked up to this little guy up here. So I'm not putting 12 volts in it, I'm putting 7.5 in. And it's going in here, so it's acting as my battery, right? So problem solved. So I might be able to get myself a little 7.5 volt power supply, little plug-in ones you get. Anyway, so I might be able to do that in the future. But anyway, for now, I'm just running with this. Negative 6.8 volts goes across to this chip here. Then we can see our battery voltage after it's been switched on is taken up here. It's fed down here. It's also fed into this IC, the TL062, which is this one up here, the power supply one, and that's this transistor here, Q15. That's them there, and this is L1 here, and you can see L1 here, and you can see where our voltage goes, our 7.5 or whatever we're putting into the battery goes. I'll go again up across here, down here into Q17. Q17 is where I've actually got my probe on, right there. Come on, focus. You see it down there, Q17. And this guy here is our plus 10. This is our DC to DC converter. You can call it, steps up the voltage. So we've got a diode here, and our 100 kilohertz reference going in here. So we've got 100 kilohertz there and 100 kilohertz there. And this is coming from the, MM74COO, this little guy down here. And it's R50. R50 is down here, which is R50 here. So, a little bit of a funny story. So I'll turn it on and I'll let you sort of see. So that's sort of the input side, and those are the, that's the AC sort of calculation board, but those are the chips I'm talking about. So, those are the 3 chips that feed into this guy, and that guy sort of drives the display, but, sort of. I'll turn it on, so we're putting our 7.5 volts in, we'll turn it on. Nothing. Have a look on the probe, turn it back off again. I'll turn it on. That's on that, remember it's on the base, that's on the base of, can I focus? No. That's from the base of, it's not focus, does it? It's on the Q17, it's on the base of this 100 kilohertz in. That's what we're probing. So I'll get back over here, I'll get you focused in on the probe. Wait a few seconds. And you can see there's some oscillation there, but if we switch on the counter, if we have a look at the counter, $999.98. So there is something there, but look at that, that doesn't look clean. I'm not sure what's going on there. Anyway, so what we do is, well, we make sure we get a clean 100 kilohertz reference. So we get a little wire and we bridge from that R50 that I was talking about, R50, where it actually explicitly says 100 kilohertz out. And we bridge across there. Only momentarily though, so I can't do 2 things at once, so I'll turn it off. Okay, so got a display. Oh, gee, come on. Alright, we'll get this going here. So I bridged from here over to here, which is this cap here. This cap is this cap here, which goes to the base. So, and I'll bridge that momentarily, just for a few seconds, maybe 5 seconds. And now we have something on display. Now, this is another problem, is it's going it's not even, it's not even showing anything, so, but anyway. But let me go down here on the, sorry, I should have measured the voltage before, but let's go on the end of this diode here. Sorry, wrong end. $16.5 volts. It's supposed to be 10 volts, 16.5. Yeah, these things are a bit, but 16.5, that's getting a bit. So, anyway. So, measured on this little transistor on the end of this little diode here. So we know this is all working fine, these diodes and the transistors working fine, but when I bridge from there to there, so something's wrong with this chip, I believe. I believe something's not right with this chip. Because now look at our pulses now. Look how clean those pulses are compared to what you saw earlier. And if I go to the counter, which is over here, 100 kilohertz, spot on. So there you go, it sort of speaks for itself. Anyway, so, and there you go, so we've got 16 volts here. So the next thing is get the voltage to sort of closer to 10 volts, and then I'll have to try and see what's wrong with that chip, and then potentially, and then try and fix the display going all, saying all sorts of weird numbers. I might not even end up doing it if it's too expensive to get it fixed, to buy too many chips. I'm not too concerned, I'm not too worried to get it fixed, but it's just another project I'm doing. So anyway, so there you go. So I'm going to try and get this to work again, even if you short these terminals here. Sorry, this would normally be connected to here, but when I cleaned it, so even if you short these two together, nothing changes. So it's not a floating voltage in the in here somewhere. So as you can see, if I change, yeah, nothing. Bent a capacitor there. Yeah, and if I turn it off, turn it back on again, it's not going to work, and we're back to those weird, not 100. That's not 100 kilohertz, because we just got a pulse and whatever we've got down there, and just rise again, pure rise. So yeah, as you can see, we're just going boom, boom. That's not 100 kilohertz. It may look like 100 kilohertz to this thing, but anyway, I'm going to see how we go. I'm going to keep playing with